Okay. Thank you, Stefano, for your presence here
Hi.
at this online event. I would like, first of all, for you to make a brief introduction. And also, if you want to introduce yourself and explain what you used parallel computing for in your career.
Absolutely, absolutely. So before, thank you for inviting me. And my name is Stefano Marrone. I'm a postdoc from University of Naples, Federico II. I actually just got my PhD a little bit more than a month ago. So I'm just now, let's say, a postdoc researcher. My research activities mostly focus on pattern recognition, so on what is usually known as artificial intelligence. And as you actually showed in your presentation, in your video, well, parallelization is extremely useful in that domain. And actually, I think nowadays it's just impossible to train and to run artificial neural networks that is just a particular kind of artificial intelligence model, but among the most computational demanding, let's say. And it's just impossible to run them without the use of parallel computing. And so that's the reason why actually also in my career, the parallel computation, and in particular the parallel toolbox with MATLAB was extremely, and still today is extremely useful. I just want to highlight that parallelization is not only on CPU. I mean, if you want to run a process on the GPU in MATLAB, and in particular, I'm talking about the training and the execution of neural network, of deep neural networks, well, you still need the parallel toolbox in that case. Otherwise, you can't run the code on a GPU. So I mean, actually, it's very, very important.
Okay, perfect. Thank you. And about this last point that you talk about, can you explain us what is the procedure to run a parallel code on a GPU with respect to the normal parallelization on the single machine?
Okay, the main difference is in the fact that on GPU is very, very unlikely that you will explicitly code for the parallel processing. I mean, the Part 4 is not working on the GPU. Okay, the only way you can use it is to parallelize over different CPUs. The way you use parallel on GPU is by using the implicit GPU computation allowed by the built-in function. So, for example, in training option, that is the function you use for training deep neural networks to set up the setting, the environment for the training, you can choose the training environment. So let's say single CPU, parallel, meaning multi-CPUs, GPU or multi-GPUs, okay? And this is the only point in which you actually force the code to run in parallel. Okay, so it's just the implicit way to run it.
So I would like to ask you, what are the main difference between the GPU and CPU? Because I know that sometimes we speak about the difference, and sometimes there's also some confusion around the what are the benefits of a GPU and what are the benefits of a CPU. Okay.
Okay. Well, clearly CPU, both of them are systems that are chips able to perform a computation. Okay. The main difference is in the fact that CPU are able to perform almost any kind of computation. Okay, they are extremely general purpose. So you can use a CPU to compute, let's say, gas dynamic equation, as well as image processing, as well as any kind of application, as any kind of program that comes in your mind. On the other hand, GPUs are very, very specialized computing facilities. The point is that they are extremely good in working with matrix of data, okay? Because talking about the hardware, while a CPU usually have 1, 2, maybe 3 computational cores, and with cores I'm not actually referring to the core, so let's say a 2-core or a 4-core CPU. I'm referring to the ALU, so actually to the arithmetic logic unit. On the GPU, you have thousands of them, but each of it is able to perform a very reduced set of instructions, and they are designed to work in a very coupled way each other. So they need to cooperate each other to perform a given task. So for example, if you have an image, and this is actually what GPU does all the time, okay? What you are just showing on your laptop or on your desktop or on your video, let's say, is just a matrix of values representing for each coordinate the brightness, the hue, and the saturation of that pixel, okay? This calculus is made by the GPU several times each second. So what actually the GPU is doing is to determine the value of the pixel for each of the pixel in your image or your screen, okay? But since they are so good with matrix, any kind of scientific computation that is based on matrix calculation can be effectively performed by a GPU. This is clearly the case for artificial neural networks, where all the computation is actually made on matrix.
And continues on this let's say topic. Can you confirm the sentence that if you have something related with image, let's say it's better to move on GPU. Otherwise, if we have a general purpose, we should stay with the CPU. So also this sentence in the field of if I face a problem with MATLAB, I need to select the right tool for the right, let's say, job. Okay.
This is true, but as I said, any kind of computation that can be moved on a matrix, on a tensor, on a vectorial computation can benefit from running on a GPU.
Okay.
And all the MATLAB's toolboxes are aware of it. So all of the toolboxes that might be based on a matrix or vectorial calculation, usually, I think almost all of them already have the ability to work on GPU. So usually you will find a flag somewhere in the option to force the execution on the GPU. Okay. And not necessarily for application intended for image processing. This is important.
Mm-hmm. Perfect. And I would like to ask the other guys if you have any question, you can feel free to ask, of course, to Stefano.
Yes, please.
Otherwise, I have another question. Maybe could you provide us with a practical example in that from which you use parallel computing and you obtain actually a better result than the normal computation, maybe in your academic career, I mean.
Okay, as I said, I actually use parallel computing every day for training and for running already trained neural networks, deep neural networks. And it's just impossible to think working and making research without using parallel computing. But if you want an example on the CPU, well, often the time, all the time I use the part 4, for example, is when I have to process huge amount of data. Let's say, for example, I have to do and redo the same operation on a huge set of different files. Okay, since all the operation can almost always be made independent each other, you can effectively use the park4 operation in that case. So it's just MATLAB. Every time you have a for, if you pay attention to the concept of slice variable, and this is something you have to study and to fully understand before using the park4 operation, well, if you pay attention to that and organize your code, write your code in a way that is effective and compliant with the park4, well, you can almost transform any for loop in a park4 loop, and this can help a lot.
Okay, thank you. And guys, do you have any question?
Sorry, I have one question.
Please go on.
So, hello.
Hi.
I'm from Politecnico di Milano. I'm a master student. So I regularly use in my thesis, I'm using the local cluster, but I want to use the external clusters. When I try to go in the settings and try to create cluster, I think I don't have the permission to create. So how can I achieve getting access to more cluster being a Politecnico di Milano student? I don't know if that
Okay.
is...
Well, there are two aspects for facing this problem. One is just, let's say, based on the license that the Politecnico bought. The other one is a technical question, the technical point, okay? Because if you want to create a remote, so a cloud pool of workers, you need the MATLAB distributed computing server. I'm not sure this is still the name used in the 2020 version. I should check. But anyway, you need another software, okay, that usually is not included in the MATLAB campus license. It's something that the university should buy separately from the campus license. I'm not sure whether the Politecnico di Milano has it or not. I can tell you that, for example, in Naples, Federico II, we have it, but it's on a different license. So if you want it, when I need to set up a new cluster, let's say with 64 cores on our HPC facility, I have to get in touch with the coordinator of that license to ask for a new license on all that machine to set up the server and then to create the cluster. And just after that, I can add it on my laptop or on my desktop account. So there are 2 points you need to understand. Maybe Alberto can help us with that. I'm not sure.
Indeed, also we try to use the online, let's say, pool with the Polytechnical license, but nowadays we are not, let's say, we did not completely understand what are the university politics about this license. So I think one of the point that we will for sure go more in deep in the future days will be to try to contact the let's say the head of the Polytechnical's softwares in order to ask for this license. Also, I would like to suggest you, if you need, let's say, more computational power, you can also look at our recent video about the use of Microsoft Azure or Amazon AWS that can, let's say, fix in some way your problem, because you can create multiple machines with a standard MATLAB install license, with a standard license, and if you can, of course, if you can split your job in multiple machines, you can do it, let's say, manually. Otherwise, you can contact us on our mail that is Daniele, I don't remember.
Yeah, matlab.polemy@gmail.com.
Exactly.
But I can confirm you everything of what Stefano and Alberto just said. The MATLAB multiple computation, so the parallel computation toolbox on MATLAB's server or your university server are a different license that is normally reserved for docs, PhDs, and researchers, of course. So if you need this point, you have to contact the coordinator of the infrastructure of Politecnico of Milan and ask the permission. I cannot guarantee that you will obtain it because is, as Stefano said, a different license. But as Alberto suggests, also in particular Azure offer for free a machine for students that have a good number of cores. I can remember 12, right? I don't know if okay. And if you have 8, sorry. And if you have if you have a problem that maybe you need this number of core, if you have a less powerful PC, you can use this part. You can find the video on a YouTube channel.
Okay. I just want to add something to this. You need the parallel distributed computing server only in two situations. The first one is when you want to make let's say you have a remote machine that you want to act as a server, and you want your machine, your MATLAB, the MATLAB instance of your machine to connect on the remote one and to perform the computation on the remote server, okay? The second situation is when you need to have the computation split over several different machines. But if you have a machine, let's say a single machine, a single server with 200 cores, you don't need the MATLAB distributed computing server. You just can go on with the local part pool, and local will leverage as many cores as available.
Right.
Okay. So you just need a good machine in that case. You don't need another license for that. And clearly, having access to the distributed computing server license just give you a software. You still need the hardware on which running your experiment. This is clear. So I think it's really important to focus on the machine before that focusing on the software.
Yeah, I completely submit.
Okay.
Augusto, if you want to ask a question.
This was the question, but he replied before, so
okay. Okay, perfect. So Torin.
What are you saying, Alberto? Hello, I'm Augusto. I joined with my sister account, but I'm sorry for this. I don't use WebEx. And I study in Politecnico Torino. And I just interested in various aspects of MATLAB and toolboxes, also because I like to find new contents for new videos to promote this as a good programming language. And I started being fond of Parallel because when I discovered the GA algorithms, I saw this parallelization of many different type of games in which you can play multiple matches on the same time and let evolve the most intelligent one. So I was just interested in discovering some.
This is a very interesting example, actually, because genetic algorithms can really benefit from the parallel computing.
Yeah. I don't know if you found any tip online, but many coders, many programmers have used this on other languages like Python or R. So I just wanted to discover the MATLAB version of it. And now I'm having another question, but I'm afraid I won't make it clear. So I try. Is the parallel computation can be interfaced with the hardware devices, in the sense that is it possible to create a software which develops many calculations on the back end, so inside the GPU and a virtual machine anyway, but many of the acquisitions are not stored already like a set of images on your desktop, but images are taken from different webcams because I want to. Is it possible? I don't know. Have you ever tried?
You're just talking about a huge privacy break. this is totally not privacy compliant, actually.
Okay, but
not focusing on this point.
Okay, I try to make an example, a stupid example.
It's not important. I got it. It was just a joke.
Okay.
Well, you can do that. I never tried, but 99.99% you can do that. But in that case, it's very likely that you will need the distributed computing server, because every time you need to make physical different machines to work together as part of a computational cluster, you need the distributed computing server, at least in MATLAB, okay, to make they work together. Because the distributed server also gives you a scheduler that decide which part of the job, which job will be executed on which machine. Okay, and this is a crucial part, the orchestration of all the algorithm, and this is crucial. Acquiring images from several cameras on several machines and then send the image to this orchestrator that will in turn distribute the computation to several computing elements is feasible, but you have to code for it. Okay? Just go for an example.
I have an example for it. I buy 3-4 webcams,
okay,
and I want to make different sketches, but I want also to add different filters. For example, recognize the eyes or a body part to substitute or recolor, and I want to do this real time. For example,
I'm not really sure that you will need multiple GPUs, for example. I think a huge one might be enough. But I'm talking about several thousand GPU, several thousand euros, so clearly. But I think a big GPU might do the job on its own. Anyway, yes, you can do that, but you have to code on yourself all the part of the code that will check, for example, in a pruning fashion, whether there is a new image to process or not. Okay? Because you cannot trigger the event, okay, there is a new file, go on and process it. You have to have a piece of code that continuously check for a new image available and to process it.
I would use a timer or an add listener object, an handle, anyway. No?
Okay, but you cannot do this directly in MATLAB. I mean, you have to do a trick. You can do that because a lot of people doesn't know that MATLAB is able to. I'm not really sure I can tell this in a public environment. So feel free to oscurate this part of the video before publishing it.
Albert, stiamo registrando.
Yes, but clearly, but you can cut this part of the video because it's not live.
Okay.
As far as I know. Anyway, you can run Java code within MATLAB, okay, natively. I was joking. I know that is a public available information, but you can run Java code. So if you need, for example, an handle that continuously check for something, for an event, you can do that. But I think, I'm not sure, but I think any piece of code that you will find about it is actually just checking over and over and over if something
like a polling
happened.
process, no?
Yes. It's just a pooling operation. I'm quite sure you cannot leverage interrupts, for example.
I think it is. There's a method.
I have a suggestion about this, if I can. I think that in Simulink there is the possibility.
In Simulink you can do that. In Simulink you can do because, that. I was talking about MATLAB.
I completely agree. In fact, I had a problem similar to the one that Augusto described. And the alternative that I found was to write the code in Simulink, and so processing this polling of file through the Simulink in the Simulink environment that is able to understand if there is file and trigger the code, the MATLAB code instead. So yeah, I thank you for the information of Java code because I didn't know it, but that's a good point.
I'm very curious to check which solution is the most effective from let's say for example in time, in terms of seconds to execute, because as far as I know, and this is true for Windows, I'm not sure whether this is true for Unix as well, but as far as I know, the OS will not provide you with an event if something happens inside a folder. Also, third-party application, let's say the Dropbox sync agent or the Google Drive, the OneDrive sync agent, as far as I know, all they do is just checking in pooling whether something changed in a set of folder they are watching. They are watching for changes. I might be wrong, but the OS should not. I'm not sure it provides the API for checking for changes.
If I can, let's say, twist a little bit the plot, speaking about code generation, because I know that you are also an expert in this field. Can you let's say speak a little bit about the possibility of export the code you just we develop in MATLAB in some other, let's say, language that can be supported natively by the GPU? I mean, I know that, for example, NVIDIA use specific code. Okay.
Yes, in GPU you can do that. Clearly, there is something important to point out before going any further. The MATLAB coder, so both the coder and the compiler, they actually behave in a different way and they will generate a different outcome. But, sorry, they are very similar to some extent. Both of them are not compliant, will not work with all the MATLAB function, okay? Every year, every release, the number of supported function increases, okay? But it's not still totally covered all the MATLAB and Simulink functions. And this is important. For example, the part 4 is not so straightforward to create the C code, for example, of something exploiting, leveraging the part 4. It works in some situation, but in many others, it may be more convenient if you write it on your own by using, for example, MPI logic, programming logic. Okay, the message passing information. Can you still hear me?
Yeah. Yes, of course.
Okay. Because my connection is not very good this moment. Focusing on the GPU is totally another story. I mean, MATLAB is able to code your MATLAB code to transform, to recode it in CUDA C. Okay? And actually, it does it very, very good. What you obtain is light years far from being humanly readable. Okay, it's extremely hard to understand why it did it in that way, but it's extremely efficient. I've seen matrix operation translated with a single for loop instead of using nested for loops. Clearly, it tries to exploit the same tricks that MATLAB already exploit for avoiding using for loops, etc. So everything you see based on the indexing operation is most of the time based on a smart and clever use of the pointers. And you will see that. If you translate the code by using the MATLAB coder, you will see how this tricks works. And so it's a nice experience. On the GPU, it's way harder to understand what's going on. But also in that case, the kernel, because to run in parallel, the idea is slightly different on GPU. What you obtain is a kernel function that is the core, as minimal as possible piece of code that will be executed by all the processing units on the GPU. And the GPU coder is quite clever. And so it usually generates kernel functions that are very, very small, very, very effective, and usually are able to exploit almost at the full power the available GPU.
Okay, so if we, let's say, develop an operation, a function, okay, that requires the use of the GPU, and we finish our coding in MATLAB, we can export it for the application to run natively on GPU, and we could expect the, let's say, comparable performance, or we have any losses or big increase in performance.
So you usually have a quite strong increase in performance. Okay. This is particularly true for the GPUs.
Okay.
And the reason is that, as you know, MATLAB is not compiled. Mm-hmm. Okay, MATLAB is interpreted every time you write something in your script, in your function, or in your command windows. However, in the last years, MATLAB is improving the just-in-time compiler, that is the piece of the runtime support that will compile that piece of code just before its execution. Okay, MATLAB keeps improving the just-in-time compiler, and the last version is extremely efficient. So before seeing a real performance increase between the interpreted function and the compiled version, you need a huge program, a huge computation to see a very strong difference between the interpreted and the compiled one. On GPUs, the compiler usually allows you to have a bigger increase in performance, but it's quite clear, quite obvious, because compiling the code allows you to skip an intermediate level, and clearly this is speed up, because with the GPU computation, you usually spend a lot of time just for synchronization between the host and the device.
Okay. I don't know if anyone have other question. Okay.
So we can thank you, Stefano, for your availability and your good information about this topic that is not so clear to students, because normally these are topics that are not explained in the normal lesson in university. So thank you, and have a nice evening to all of you.
Also to the other attendings, we suggest you to follow us on our platform to stay focused and keep updated on our next events. Also, hopefully with new guests, and also Stefano, if in the future will join us again.
Absolutely.
Okay. Thank you, and
thank you.
Good evening.
Bye-bye.
Bye-bye.